Hello students, welcome back to the lecture class 2 in joining process. So today we are going to discuss about the brazing. So this is the second process in the joining module 4 chapter 2. As I told you in the last lecture class, so we have three processes in joining. One is soldering, next is brazing, third one is last one is welding process. So today's class is only about the brazing process. We'll start with the brazing. Contents of this are principle of brazing, fluxes used in brazing, advantages, disadvantages, application of brazing, types of brazing versus soldering. It is very important. What are the differences between brazing versus soldering? So principle of brazing. First, so brazing is also a method of joining. We are using this brazing method for similar and dissimilar metals, but temperature is more than 450 degrees Celsius. In soldering, temperature is 450 degrees Celsius, but it is above 450 degrees Celsius, but below the melting point of the base metal. So base metal melting point is below, that is base metal is having a like let us say some 800 degrees Celsius, but that we are not reaching to 800 degrees Celsius. Less than that, the base metal temperature. Base metal means what? Workpiece. The what workpieces you wanted to join, that is called as a base metal. So that base metal, it is below the melting point of the base metal only. We are not melting that base metal. Okay. So it is above the 450 degrees Celsius, but below the base metal melting point. Okay, below the base metal melting point. Okay, so base metal melting point is 800 degrees Celsius, means below that only you have to use. That is a brazing. Okay, that we are not totally melting the base metal. Filler rod we are using here. Filler rod here is called as a spelter. You can see the spelling there is called as a spelter. Okay, so spelter, there it was a solder, but here it is a spelter. It is a non-ferrous alloy. Spelter is made up of a non-ferrous metal or alloy. Non-ferrous means not a ferrous. Okay, it may be aluminum, zinc, copper, tin. It is not at all a ferrous metal. Okay, it is non-ferrous metal, or it may be alloy also. So mostly we use copper and copper alloys for this, or aluminum alloys, silver alloys. So the mostly used spelters for the brazing. Now spelters means like a solders. Okay, as a filler. Filler is also called as a spelter. How it flows by means of capillary force. How the molten filler flows, because we are melting the filler. When in the filler means what? Spelter. When you melt it, it has to convert the solid into liquid. That liquid, the molten filler, it has to flow into the gaps where you want to join the two components. Okay, by means of capillary force. By means of a capillary force, the filler metal cools down and solidifies, forming a strong metallurgical joint. Okay, so there are two gaps are there. So in that gap you have to fill some material. What material? That is using the spelter. So when you melt the spelter, that becomes a molten metal. It is able to move. Okay, it is a liquid form. That rod, the filler rod, it will be a liquid form. It starts flowing by capillary force, and it will sit in the gap between the two components to be joined. And after, once it solidifies, because the molten state has to be converted into liquid solid state. Okay, molten metal means what? Molten metal means the liquid, the metal in liquid condition, it is in a hot condition. Liquid, okay, hot liquid is liquid in hot conditions called as a molten metal. So once it solidifies after cooling, it becomes a joint. Okay, the filler metal cools down, it becomes a strong metallurgical joint. Metallurgical joint, why we are saying metallurgical joint means because metallurgical changes would have taken place. Okay, there may be changes in the metallurgical metallography. The structure would have changed. Body centered cubic would have changed, hexagonally closed packed, BCC into FCP or FCP. Anything would have changed. The metallurgical structure would have changed because of temperature. As I told you in the last class, temperature, the changes would have taken place. The grain structure of the metal would have changed. So that is why the metallurgical joint. So as the metallurgy changes, the strength also changes. Strength may increase or decrease. All these things we have to do. We have to investigate that. Once you just join, what is happening for a strength, mechanical strength for it, whether it is increased or decreased, well, at least to near to the base metal. Okay, so for example, base metal is around 300 megapascal. To 300 megapascal, whether once after joining, how much you got? So let us say 150 megapascal. Joint strength is 150 megapascal. So 150 megapascal, 50% only you have achieved. So total base metal, what the base metal we have used is having a 300 megapascal. But when you join the two base metals, when you find out the joint strength, you got 150 megapascal. So 150 by 300 only, that is 150 by output is 150 megabyte. You got 300. So only it is a 50%. So 50% efficiency. Joint efficiency is what? 50%. Okay, so if you got a 200 megapascal, accordingly that you are going to get 200 by 300. Okay, 300 by 300 is 1. 100% is not possible. Okay, joint strength 100% is not possible. Less than 100% is possible. But to nearly you require some maximum joint strength so that you can use brazing effectively in some applications. Okay, so that is metallurgical joint. A filler metal, once it cools down and solidifies, forming a strong metallurgical joint. The metallurgical properties changes, mechanical properties also changes for a joint. Next we see this, the brazing principle figure here. Here we are using a flame. Okay, we are using a flame to just heat the surface. So this is a job, this is also a job. Two jobs are there. You need to join this electrical part in this square part. You require a welding torch. In this, oxygen and acetylene would have used. So this is a filler rod. This filler rod, you have to melt this filler rod. Okay, once you melt this, so the molten metal flows into the gap, and after solidification, the two metal becomes joined. It's very simple. Okay, so this portion, a cylindrical part and a square part, you need to join. So by means of a brazing. So here brazing process. So for heating this filler rod means what? Is a spelter. Okay, spelter. So this spelter you have to heat this. So once you heat this, okay, this will it will become molten metal. It starts liquefying. Okay, but in hot condition it starts flowing. The solid part becomes a liquid part, and it will go and accumulate in the joint gap. And after solidification, this both the metal job 1 and job 2 both will become a strong joint. So this is what the brazing. Next, fluxes. We need to use fluxes also here. Okay, the same purpose in soldering. The purpose of flux in the soldering is the same in the case of brazing also. It will say that is for you have to prevent oxidation. You have to prevent the oxidation process. Next, you have to make the wet, the area, workpiece area, you have to make it wet. For that, you have to use the same case of soldering also. There also, you have to prevent oxidation. You have to preheat the metal. Preheat the metal. It also cleans the surface by dissolving the metal oxides. So these are the functions of the flux. Okay, the functions what you use, what we said. What we are going to write also in the examination for the soldering, the same thing is applicable here also in the case of brazing. What are the functions of fluxes means you need to write the same functions of flux in the case of brazing also. There is no changes. Okay, but the fluxes may differ. There we use different, here we use different. Here borax or a mixture of borax with other chemicals we use. Okay, so there we use rosine alcohols. So here borax and mixture of borax with other chemicals we need to use here as a fluxes. So how to apply the flux? The same. Fluxes are available in the liquid form, in the paste form, powder form available, the fluxes. So you have one of the method of applying a flux is you can dip it. The powder you can dip it. By dipping also you can do it. So applying the flux in powder form is to dip the heated end of the filler rod into the container of the powder flux. That you have to dip that filler rod, you have to dip that in the powder, apply it on the surface so that it will not stick, allowing the flux to stick to the filler rod. Next, another method is to heat the base metal slightly and sprinkle the powder flux. So heat the base metal slightly, not fully, slightly you heat and sprinkle the powder, that is flux powder, over the workpiece. And over the workpiece means where we want to make a joint. Okay, allowing the flux to partly melt and stick to the base metal. Sometimes it is desirable to mix the powder flux with a clean water also, distilled water also, to form a paste. So in powder form is available, liquid form is available, paste form also it is available. So flux in either paste or liquid form can be applied with a brush also to the joint. Better results you are going to get with this when you apply the brush. Okay. So and also you can give some kind of coating also. So these are the how we have to apply the flux in the for the case of brazing on the workpiece. Next we go for some of the commercial fluxes also it is there, like small amounts of phosphorus and halogen salts, iodine, bromine, chlorine, arsenic. Next, advantages. Advantages you can see here. Any metals can be joined, including dissimilar metals. Certain brazing methods can be performed quickly. Brazing can be applied to join thin-walled parts that cannot be welded. So, thin parts, okay, which you cannot weld it, because if you weld it, it will melt it. That is why you cannot go for welding for such applications. For such applications or such components, you can go for brazing process. But the thin is not like soldering. Okay, for soldering it becomes heavy for that. The thin what we have used here, thin walled parts. So this thin, it means that this for soldering it is not thin. Soldering it becomes thick, but brazing for welding it is thin. For brazing it is suitable like that. So brazing can be applied to join thin walled parts that cannot be welded. So in general, less heat and power are required than fusion welding. So it is a easily automatic process. Dissimilar parts can be joined, as I told you. So much heat is not involved in this. So low thermal distortions are there and low residual stresses in the joint. Next we go for disadvantages. So joint strength is generally less than the weld. Yes, obviously. So joint strength, because it is not a permanent joint. Welding is only the permanent joint. So you can just remove it by your hand. You can break the joint by your hand itself. So although strength of a good brazed joint is greater than that of filler metal, it is likely to be less than that base metal. So always the joint strength is less than the base metal. High service temperature may weaken the brazed joint. So when you use a high temperature, therefore the joint strength of the brazing will decrease. The color of the metal in brazed joint may not match the color of the base metal parts. That is a very problem. The color of the metal in brazed joint may not be match the color of the base metal part. Okay. So it is expensive. The filler metal is expensive. Large and thick sections cannot be brazed efficiently. Flux residues must be removed after brazing, otherwise which may cause corrosion. So these are some of the disadvantages of the brazing. Next, applications of brazing. It is used to fastening radiators. You want to join the radiators parts. There you can use electrical parts, tanks, pipe fittings, plumbings also you can use, axles and more. Okay, it can be welded to dissimilar metal, cast metal, ferrous metal. You can use it for ferrous metals also, bronze metals also. Okay, copper metals. You can use copper metals, bronze alloys. It is used to join a joint of band saws and bicycle parts such as the rims and frames. They also we can use as the applications, the brazing. Next comes types of brazing. Types of brazing means what? What are all the ways you can heat the part? Okay, the heating conditions, how we are doing the heating conditions. That is the main thing. So here 5 ways you can heat the part. 5 ways are there we can heat the part. First one is torch brazing. It is generally used, torch brazing. Next is furnace brazing. Next is a dip brazing, resistance brazing, induction brazing. So these are the 5 ways in which you can braze. You can heat the metal. That is the types of brazing. So brazing methods are same. Brazing concept is same. But what are all the ways in which you can heat the metal? That you can classify as a 5. So many are there. So just from syllabus point of view, some 5 are given here. Okay, torch brazing. That means you have to use, as I told you, you have to use oxygen, acetylene gas. Both the gases you have to mix in proper proportions. Then you have to use the lighter. When you use the lighter, you will get the flame. So this flame can be used to heat the metal by using a filler rod, and that you can join them 2 parts. So this is you can use you can see here flame you are getting, the 2 pipes we are joining here. Okay, and these are the oxygen and acetylene cylinders. Why this is a what do you call this, a torch. So through this only we are going to get a flame. You have to mix this one with the proper proportions. Then you have to adjust the flow of gases, oxygen and acetylene. So 1:1 ratio you have to mix it. You will get a gas outside, mixed gas you will get outside. So this mixed gas, when you use the lighter to ignite the gas, you will get a flame. So that is the flame only you are seeing here. Here also you are seeing. Okay, so then we will get a heat, and we can join the 2 parts. So this is about the torch brazing. So as usual, you have to just prepare the surface. That is, you preparation of surface. That is, you have to remove the dust, grease, other oxides. You have to clean. You have to apply the flux. Okay, at the joint. You have to apply the flux at the joint. You can use the borax, boric acids, fluorides, chlorides, or these are the commonly used flux materials. Later you have to use the torch, for just welding torch. Filler metal is then placed at the joint. Then you start heating that. You will get heated with the carbrizing flame. Carbrizing flame means more amount of acetylene will be there than the oxygen. More amount of oxygen. The proportion of the so here oxygen gas acetylene, as is oxygen acetylene, as I told you, 2 cylinders are there. So if you use 1% of oxygen, 1% of acetylene, you get a neutral flame. So more amount of acetylene if you use, you will, and more amount of acetylene than the oxygen if you use, you are going to get a carbrizing flame. So we mostly use the carbrizing flame. Okay, the filler rod, you have to melt the filler rod using that flame. Okay, the molten metal from the filler rod, it will go to the nearer to the joint where we want to join. By capillary action, the workpiece allowed to cool for some times, and you will get a joint. Then you can remove that. You can clean it. You can remove the fluxes, residues, in order to prevent the corrosion. So compulsory after a brazing process, you have to remove the corrosion. You have to remove the fluxes. Okay, extra fluxes which is there on the part of a component, you have to remove it. You have to clean it, otherwise it may corrode future. Okay, that is the torch brazing. Next is furnace brazing. In furnace brazing, you can see, I will show this part here. So many components are there here. So many components. These components at a time you have to keep it inside the furnace. You can see the furnace temperature here. At a time you can keep all the components inside the furnace and close it, and you will get a brazed product. So here one more figure. So many components are there here. These so many components at a time you are keeping inside the furnace. Okay, after some time you are removing it. Then you will get the brazed part. Brazed part means joint. So you will get a joint. So you have to apply it, all the flux, you have to apply the flux, everything you have to apply it, and you have to keep it inside the furnace by using a conveyor belt. So that is the furnace brazing. Here you can see a filler metals diagram, line diagram. Filler metals are there. This is the furnace, melts and flows. Filler metal melts and flows. It's a brazed joint. So it's a conveyor. Is a conveyor. So this is a filler metal. You have to keep it here. Okay. So once this entire component goes inside, it will melt. The filler metal will melt and flows inside the joint, and afterwards it becomes a strong joint here. It has come outside. So that's how the furnace brazing is carried out. It is used high temperature. This is non-ferrous filler metal you have to use. The melting temperature is above 450 degrees Celsius, but below the melting temperature of the base metal. The filler metal is distributed in the joint by capillary action. That is, as I told you. Next, it is suitable for fabricating complete brazements. A big joint is there, complete entire component to be brazed. So in such cases, it is used entire component, big brazements. It does not require a highly skilled operator. For this, highly skilled operator is not required. Pre-fluxed or pre-cleaned parts with the filler metal pre-placed at the points. Pre-placed means this is what pre-placed. First itself we have to place a filler metal. A pre-placed or a pre-cleaned parts, pre-fluxed or a pre-cleaned parts. The filler metal is pre-placed at the joints or heated in the furnace. So brazing can be done in an air furnace. Okay, it can be done in air furnace with a flux through a protective atmosphere usually needed. The type of atmosphere required depends on the atmosphere of combustion natural gas or cracked ammonia. So dry hydrogen, a powerful reducing agent, can be used for the brazing stainless steel, nickels, cobalt and iron base alloys. So this is about the furnace brazing. Next, dip brazing. So in the dip brazing, you have to dip entire metal to be joined here. You dip it in this, as called dip brazing. So in this, it is used aluminum assemblies. It is mostly used for aluminum assembly. Temperature of molten flux bath can be controlled here. The molten bath serves as a both heating medium and fluxing agent here. So uniform heating to brazing temperature is achieved rapidly. Parts are cleaned, assembled and held together in fixtures during brazing. Parts are normally preheated before the immersion. So before immersing this, you have to preheat and you have to immerse. After brazing, in order to prevent the corrosion. So this is the next one, is resistance brazing. So resistance brazing here, why we are using resistance brazing? It is not suitable for special joints. It is not suited for special joints where heat must be restricted to a localized area without overheating the surrounding parts. The heat required for brazing is produced due to an electrical resistance offered by the joint members to flow of the current. So resistance means what? Resistance means flow of opposing force. Okay, once opposing force is there, automatically you will get a heat. So you can see here two components, current force is there, two parts you have to join. These are the electrodes, currented with electric supply is there. So you offer a resistance. Once you offer resistance, you will get a heat, and because of that heat you will get the joint here. Next is induction brazing. So in induction brazing, where the particular component you want to be inducted, so through inductance also you get the heating. You can go for a joining the process through induction process. Here we use alternating electromagnetic field of high frequency for heating purpose, for heating the workpieces, and together with the flux and filler metal placed in the joint. Filler metal we have to place it in the joint. So this workpiece is heated selectively by coil induction brazing, reduces the unwanted part distortion or annealing. So induction heating brings the joint rapidly to brazing temperatures. This is one of the fastest method in the brazing process. So that is why induction stove, you might have seen the induction stoves. So induction stoves, you will get a lot of immediately you will get the heat and can cook the food. Induction stoves compared to the natural gas stoves. Next, differences between brazing and welding. So in brazing, we say the filler rod as a spelter, but in soldering we say solder. Second difference is melting point of the filler metal is above 450 degrees Celsius but below the melting point of the workpiece. But in soldering, melting point is filler metal is below 450 degrees Celsius. In brazing, stronger joints are produced, but in soldering, less stronger joints compared to the brazing. Next, fourth one is brazing joints resist corrosion. So it has the capacity to resist the corrosion. But in soldering, it does not have do not resist the corrosion. So it does not have any corrosion resistance properties. So brazing is costlier and that is cheaper. So brazing you can use for, you can write still more like can be used for thick walled compared to the soldering. So in soldering mainly is for thin one, but this one brazing can go for minimum thickness. Okay, some thickness is required for brazing, you can use it. When soldering, thin wall is applicable for thin walls and is only applicable for electronic components, not for much for like mechanical parts and for structures. But brazing can be used for structures, mechanical structures, assemblies, like that we can use it, you can write it for the differences in the brazing. So this is all about the brazing process. So this is also a metal joining process like soldering, brazing we have completed. Last topic is welding. So that the welding we will discuss in the next class. So thank you for watching the video. Okay. Again next class we will discuss about the welding.